Okay, here's a polynomial. G of x is x to the fifth minus x to the fourth minus x cubed plus x squared minus 2x plus 2. We're going to analyze this and find the zeros and make a graph of it. And I'll just take notes here as I go and think out loud. Let's start with the simplest ideas. We can see that this is a fifth degree polynomial. So that means that there will be 5 zeros at most. In other words, this will cross the x-axis 5 times or fewer. And then we can also look at Descartes' Rule of Signs because that's pretty easy. So from Descartes' Rule of Signs, we go left to right and we count the number of sign changes. So this is positive, that's a positive x to the fifth. So it turns negative here, so that's one sign change. And then back to positive right there, that's 2. And then negative again right there. And then going on to the right, positive again right there. So that's four sign changes. Okay, 4 sign changes means that there are 4, 2, or 0 positive zeros. Okay, and then we can also analyze g of negative x. So let's write this down. G of negative x would be, let's see, x to the fifth. If we put in negative x, that would become a negative x to the fifth. And if we have this minus sign here, there, and then if we put in a negative x right there, the even power still keeps that as x to the fourth. But if we put in a negative x right there, we get a sign change. So this would be a plus x cubed. And then it's a plus x squared because the even power right there would keep it positive. And if we put in a negative x right there, that becomes a plus 2x plus 2. So look at this. We start out negative, and then we switch to positive, and we remain positive. So there's only one sign change going left to right. So that means there's only one negative zero at most. One negative zero or fewer, so 1 or none. Now this is very non-specific information. This doesn't tell us where those zeros might be or even exactly how many, but it does start to give us an idea of what the graph is going to look like. Now let's think about the rational zeros. Let's look at this this 2 right here, and then over here this is a coefficient of 1. That's a 1 x to the fifth right there. So the rational zeros are going to be pretty easy to think about. We just need to deal with factors of 2 over factors of 1. So that's going to be 2 over 1 or 1 over 1. So that's just plus or minus 1 or plus or minus 2. So there's only 4 possible rational zeros. So those will be pretty easy to work with. I'm going to erase some things here so I have a little bit more room on my page. Okay. So let's start testing these, and we'll just start with 1. So we write our coefficients down. 1, negative 1, negative 1, 1, negative 2, and 2. And we put a 1 out here. Okay, bring down the 1. 1 times 1 is 1, and we add those, and we get a 0. 0 times 1 is 0. We add those, we get a negative 1. Negative 1 times negative 1 is negative 1. We add those, and we get a 0. And then 0 times 1 is 0. We add those, we get a negative 2. Hey, look at this. Negative 2 times 1 is negative 2. We add those, we get a 0. So there we go. That means x minus 1 is a factor. And we found one of the zeros. X equals 1 is one of the 0. And these coefficients down here will give us the other factor. So our original polynomial up here, g of x, factors like this. X minus 1 times the polynomial made here. So this is going to start at x to the fourth. That's x to the fourth plus 0x cubed minus 1x squared plus 0x minus 2. Now that is really nice, and the reason that this is nice is because this piece right here, this fourth degree, is actually in quadratic form, and it can be factored. Watch this. I'll keep this x minus 1 here, and then this factors as x squared minus 2 times x squared plus 1. All right? And we can always deal with a quadratic, and here we have two quadratic factors, so from here, there's nothing terribly difficult. I can find the rest of the factors. Watch this. This is x minus 1, and from this one, think of it like this. Think x squared minus 2 equals 0. So x squared equals 2. So x is equal to plus or minus the square root of 2. And we can do something similar right here. We'll get a complex root. Watch this. X squared plus 1 is 0. So x squared is equal to negative 1. So x is equal to plus or minus I. So if you really want to factor the whole thing, it could be written like this. X minus 1 times x plus square root of 2 times x minus square root of 2 times x plus I times x minus I. Or if you want to avoid the complex numbers, you could say x minus 1, x plus square root of 2, x minus square root of 2, and that's just x squared plus 1. Those two together. But these three right here give you your real zeros, your real number zeros. So there are 3 real zeros, and we found them by factoring. And the real zeros are 1, square root of 2, and negative square root of 2. And now we can think about graphing this. Let's draw some axes here, x and y. And we said it had a 0 at 1. So I'll plot a point there. And at square root of 2, which is going to be about 1.4, so that's real close together. And at negative square root of 2 over here. And the other two zeros, it's 5th degree, but the other two zeros are complex, so they don't show up on the axis. I do know it's going to do something like this. It's 5th degree, right? So it's going to look something like that. But I don't know if it's doing this or if it's doing something like this. I don't know exactly what it looks like yet. But I do know it's going to be going way up on the right side and way down on the left side. Something like this and that. And I know that all of these zeros have a multiplicity of 1. So it crosses the axis at these 3 places. So it doesn't do a touch and go at any of these places. It crosses the axis at all of those. And from here, I'll just plot some points. Put in some numbers for x and calculate some numbers for y, or for g of x, as we'll call it this time. And if I do that, if I put in negative 2 for x, then this ends up being negative 2 to the 5th, which is negative 32, minus x to the 4th, that's minus 16. Minus x cubed, which is minus negative 8 or plus 8, and then plus 4 plus 4 plus 2. That comes out to be negative 30. So at negative 2, the value of the function is way down there off my graph here. If I put in negative 1 for x, you just work out all of this, it comes out to be 4. Okay. I get that because negative 1 to the 5th is negative 1, and then negative 1 to the 4th is 1, so it's minus 1, and then minus negative 1, and then plus 1, plus 2, plus 2, yeah, it equals 4. And so I can plot a point there at negative 1. We're up there at a value of 4. Okay, that's good to know. And then when x is equal to 0, this is easy. Just put in a 0 right there and you get 2. So when x is equal to 0, g of x is equal to 2. So let's plot that. Now the shape of the graph is starting to emerge over here. Let's do one more. If I put in x equals 2, this comes out to 32 minus 16 minus 8 plus 4 minus 4 plus 2. That works out to 10. So when x equals 2, we're way on up there off the chart. And let's draw on the graph. Something like this. It's going down very fast down there, and then it crosses the axis just barely there, and then it's going up very fast here. And that's not perfect, but it's a pretty decent graph of g of x.